You'll recall that multiplying and dividing fractions was easier than adding and subtracting because you don't need a common denominator. When you multiply, you simply multiply the numerators and then multiply the denominators. When you divide, you simply flip over the second fraction and then make it a multiplication problem. That's what we're going to do in this section, and we'll reduce all of the fractions that result. Before we do any multiplication, we're going to factor everything in the problem, all the numerators, all the denominators, and then cancel any common factors in the numerator and denominator. So you'll notice that I'm going to cancel the p minus 1s because there's 1 in the numerator and 1 in the denominator, and I'm canceling one of the p's in 3p squared. That's why I only crossed off the 2 with the p in the denominator of the first fraction. Final answer, the only thing that's left is 4 times 3, or 12 on the top with a p, and 5 on the bottom, so it's 12p over 5. I'm going to cancel the first fraction numerator and denominator as the difference of squares. So the top factor is a minus 4a plus 4, and the bottom a minus 5a plus 5. I'll be able to cancel the 2a minus 4s, one on the top with one on the bottom, and the 2a minus 5s, one on the top and one on the bottom. I'm left with a plus 4 over a plus 5. Remember, we cannot cancel the a's. It's not equal to 4/5. They have to be multiplied to cancel. Let's factor the second fraction, also differences of squares. So the numerator factors x minus 2x plus 2 and the denominator x minus 3x plus 3. I'll be able to cancel the 2x minus 2's and the 2x minus 3's. I'm left with x plus 2 over x plus 3. First fraction, numerator factors x minus 2x plus 2, and I can take a 3 out of the bottom. And the second fraction, I can factor the denominator, x plus 4x plus 2. Pause the video if you're having trouble with factorization and figure it out. Cancel the 2x minus 4's and cancel the 2x plus 2's, and you end up with x minus 2 over 3 times the quantity of x plus 4. You could multiply that out in the denominator if you wanted to, but it's not necessary. While I factor the first fraction, I'm going to put it over 1. It factors x minus 7x plus 7. The two x plus 7's cancel. I'm left with 5 times the quantity of x minus 7 over 1. It's not necessary to write the 1, and you could distribute if you wanted to. Let's factor a 3 out of the numerator of the first fraction and then factor the denominator of the second. I'll cancel the 2 3's and the x minus 1, and I'm left with just 1 over x minus 2. Remember, if everything cancels in the numerator, you have to put a 1 there. Factor all the parts of these fractions. The top left factors x minus 3 squared, so I'm going to write that twice, and the top right factors x plus 2x minus 2. The x plus 2's and the x minus 3's cancel. Notice I only cancel one of the x minus 3's. The final answer is x minus 3 times x plus 2. That's over 1, but it's not necessary to write the 1. Take a couple of minutes and write down the attendance codes. Remember, you only have to send me 1 for attendance credit and 1 on the bonus for the quizzes or tests, but you can put them both on your bingo card if you're playing. The thing that needs factored is the numerator on the first fraction. It factors x plus 3, x plus 4. Although I did factor 12 is 3 times 4, so I could cancel the 4's and the x plus 4's. Final answer is x plus 3 over 3. Remember, do not cancel the 3's. There's a plus sign up there. You have to be multiplied. Before I can cancel any numerators and denominators, I need to flip the second one over and make it multiplication. After I do that, nothing needs factored. I can cancel the x plus y's because x plus y and y plus x are the same thing. And then I can cancel the x minus y and y minus x if I introduce a negative 1, like I did earlier. Since everything cancels here and the only thing that's left is the negative 1, the solution is minus 1. And I'm going to factor both fractions and flip the second one over at the same time. first fraction factor is x minus 7, x plus 2. I wrote that over 1. And then I'm going to flip the second one over, which makes the denominator factor x minus 7, x plus 3. Notice the two x minus 7's cancel, as do the two x plus 3's. So there is nothing left in the denominator but a 1. Final answer is x plus 2. Not necessary to write it over 1. To factor everything and flip the second one over at the same time. So the top left factor is x minus 2 times x minus 2, the bottom left 5 times x minus 2. Then I have 5 times 11 on the top because I'm flipping it over, and on the bottom 11 times the quantity of x minus 2. Notice that absolutely everything in this whole problem cancels. You'll find that happening once in a while. And that means the final solution is just equal to 1. Remember, never 0, always 1 when everything cancels. 12, since I have to flip the second one over, but it isn't a fraction, I'm going to write it over 1 before I flip it. Top left factor is x plus 8, x plus 5, and then the second fraction ends up being 1 over x plus 8 when I change it to multiplication. The x plus 8's cancel, I'm left with x plus 5 over x minus 5. Remember, do not cancel anything more than that because those are subtracted and added, not multiplied. I'm going to flip the second one over and factor everything. And when I do, I end up with a bunch of x minus 9s. I'm canceled 2 on the top with 2 on the bottom. And when I'm finished, I end up with just x times x plus 9. Notice that there's a 1 on the bottom, but it's not necessary to write it. And I could distribute that if I wanted to, but also that's not necessary. Flip the second one over and factor everything at the same time. Cancel 2 x minus 2's and 2 x minus 4's, 1 on the top and 1 on the bottom. When you do, you're still left with 2 x minus 2's in the numerator and 2 x minus 3's in the denominator. You could write that as x minus 2 to the second power, or you could multiply it out, and x minus 3 to the second power on the denominator, or multiply that out, but neither is necessary. Let's factor the first fraction and flip the second fraction over. After I do, I'm going to be able to cancel an x minus 8 on the top and bottom and an x minus 4 on the top and bottom. When I do, I end up with x plus 8 over x plus 4. Remember, that's not equal to 8 over 4. You can't cancel parts of it. You can only cancel things that are multiplied.